డిస్కషన్ ఆపేద్దామా? Good evening, everyone. We shall start the webinar in a couple of minutes, just in 2 minutes. So before starting the webinar, so I would like to know from which background you are from. So either BTech or MTech. So can you please comment in the comment section so that we can emphasize more based on your discipline. So I just wanted to know whether you are from BTech or MTech. So can you please let me know whether you are from BTech or MTech? All right. Yeah, so I have rectified that. Now I hope I would be audible. Hello. Check. Okay. Tension. No. This is the maximum. Will there be any settings in YouTube? I'll try to talk louder. Yes, we shall start now. Good evening, everybody. I welcome you all for the webinar on behalf of CivilTech. At the outset, we regret for the inconvenience caused due to the change in the stream link. It was due to some technical error. We at CivilTech give due priority and emphasis to experiential learning, which made us different from others. So through this webinar, we wish to provide a brief insight on the applications of GIS in civil engineering by alluding more examples. We shall try to give as detail as possible, and we hope you'll all enjoy and get good exposure on the applications of GIS in civil engineering. So going into the presentation, in this webinar, we'll be covering what exactly GIS is. So at the outset, we'll go into the brief historical developments of GIS, and then we'll go into knowing what is GIS and why exactly do we need GIS, and where all can we apply this in the field of civil engineering. Right, so going ahead, so GIS is not a recent development. So the stepping stones for GIS were laid in the year 1963. Right, in the 1963 itself, the concepts of GIS were introduced. So after that, it was brought into practice in Canada in the year 1965. So because in those days, you know, drawing the electric lines, pipeline network, it was very difficult to do it manually. So a person named Roger Tomilson from Canada used to work for the municipality of Canada. So he has started applying the concepts of GIS and brought a computerized GIS in the year 1965. And later on in the year 1969, so a person, Jack Dangermond, who is from Harvard, so he started one institute which was called as Environmental System Research Institute, and later it was commercialized in the year 1981. And the softwares what we have been using these days, ArcGIS, so it is what the output of ESRI is, right? The full form of ESRI is Environmental Systems Research Institute. So it is a commercial software, so which was the ArcMap or ArcGIS what we are using these days is, I mean, it was commercialized in the year 1981. Now let us try to understand. So will GIS be useful, or how is it different from the existing commercial softwares? Right? We all know AutoCAD and we have been using it. So still I'm getting some comments that the volume is little low. So it is actually full in R. So can you please plug your earphones to have a better clarity? So please do that, and then confirm me in the comment section if it is audible clearly if you are using earphones. So meanwhile, I'll once again check it in my right. So as per the settings, it is okay. So kindly plug in your earphones. Now I hope I'm audible, right? So kindly confirm it in the comment section. So we shall go on with the coming slides. So now let us try to understand. So why exactly we are using GIS, and let us try to compare it with the existing softwares. So now let us consider AutoCAD. So in AutoCAD, we have been drawing plans. So whatever the building plan is, we just draw using straight lines, curves, everything, right? But how exactly is GIS different from AutoCAD? Now let us try to understand it with a small example. So on the right side of the screen, so we have shown a three-dimensional profile of a particular region in Jammu, right? So the major dimension or the major emphasis what GIS gives us is the scenario analysis. Now if you closely look at the diagram on the right side, you can see that the water is slowly approaching through the channel, and you can visualize which part of the area is going to drown down first if floods come, right? So this kind of analysis is not possible if you do it in AutoCAD, right? So that's the major objective of using GIS. So we can bring in as many parameters and then keep approaching towards the solution. So that's the major advantage of using GIS, and this is how it is different from the existing softwares. So that's why, because of these advantages, GIS has been rapidly used, and it has been in many of the areas we have been using it. For example, if you look at the smart city mission started by the central government, right? So they are trying to convert every city into smart, so wherein the spatial data, everything plays a very key role, right? So now let us try to look at where can we use this GIS and all. Before going into the applications of GIS, let us try to understand what exactly geographical information system is. Since it's a blend of both the BTech and MTech, we are trying to cover all the basics. So let us discretize the word geographical information system, right? When I say geographical, it states that what exactly is there at a particular location. So predominantly it answers two questions. So where something is, for example, like I can ask a question, where is Delhi? Or I can give a question, what is there at 73.23 north and 28.43 south, right? So you can get to know what exactly is there at a particular location, and you know the location from the word geographic and from the word information. So you are collecting what exactly is there at this particular location, and after collecting the essential information, we try to manipulate, summarize, edit, visualize, and do multiple operations to get the desired output, right? So just to visualize what exactly GIS is, so we are playing with the spatial data. So whenever you come across a word data in GIS, it means by default it is a spatial data. So once I collect the spatial data, I capture it, I store it, I manipulate, I analyze, I manage, and finally, as a GIS planner, we provide a map as an output to the end user. So the desired output will always be in terms of a map, right? So this is the classical definition of geographical information systems, what you come across in various blogs, various textbooks, or various research articles. Now let us move on to look at the various fields in which GIS can be used. So predominantly we are focusing civil engineering. So in geotechnical engineering, we can use GIS. In construction technology, in transportation engineering, hydraulics, water resource, environmental, structural and urban planning. In each and every of these disciplines, we can use GIS in order to arrive at a particular solution. Now let us look at few examples which are quite interesting. You need to focus at each and every example and the data which is required to cover it. The first example is urban heat island effect. So what is urban heat island effect, right? So over the years, what is happening? The population is increasing, cities are growing. And when I say cities are growing, indirectly we are converting the waste land or the useful land into a concrete blocks, right? So because we are building many structures, because of which the pervious land is decreasing. So urban heat island effect is a phenomenon where, for example, this is the city region, right? So this is a commercial, city, urban, residential, park. So these are the different categories mentioned. In We say that in a particular city, if urban heat island effect is present or not. So if you want to know the answer for that question, definitely if you measure the temperature in the city region compared to the surrounding villages. So let us say here in the village on a particular day, let us say today, the temperature is around 27, and this is also a rural area which is adjacent to the city, so the temperature would be around 26 or 27. But you'll observe that the temperature in the city region will be around 32, 34. That depends upon the intensity of urban heat island effect. So if it is more intense, you will find the temperature would be plus or minus 8. So depending upon place to place. So if you observe this kind of phenomenon, then we state that this particular city is experiencing urban heat island effect. So this is not a new phenomena. So most of the urban agglomerates are experiencing this kind of phenomena. So a study was conducted recently by few of the researchers, and it is identified that these are the different locations which are experiencing the urban heat island effect, which means that the temperature in these localities are comparably higher when compared to the temperature in the nearby surroundings. So now if I ask you to find out, let us consider Chennai. So if I ask you to find out, is Chennai experiencing urban heat island effect? So if I pose this question to you, so by definition you know what urban heat island effect is. So we just tried understanding it. So urban heat island effect means the city area will be experiencing higher temperature related to the rural areas, right? So now if I ask you to measure the temperature, so you need to hold a thermometer, you need to conduct a lot of surveys and take several readings, take it in Excel or take it somewhere, and finally you will come to know whether the city is experiencing the temperature or not. But if I ask you to do it for every city and I put a time constraint for you that you need to perform an experiment within 2 days, obviously it is not at all possible, right? Because when you take a temperature value, you need to take at least few data points and take an average. Now here comes the use of GIS. So GIS actually helps you to find out, to play with the spatial data. So if you just recall with the questions, right? So if you just recall with what we have learned before, so GIS, we are playing, we are manipulating, we are analyzing. So a lot of things are being done using the data, right? So what I'm going to do right now, so I'm going to collect certain satellite images and then I process the images to find whether the temperature at a locality is high or low comparatively with the surrounding area. So that will be easy, right? So I can just download one satellite image and then find out how the temperature is over the entire country in just 2-3 hours. The only thing is you need to know where to download the data. So from which satellite you need to obtain the data. So once I obtain the data, which algorithms do I have to use it? And once I get the algorithms, how do I interpret the results that I get? So if you know these typical things, then definitely you can actually find out whether the city is experiencing this urban heat island effect or not. Right, this is one of the key research area many of the researchers are doing. If you people are from MTech, then definitely you can publish one scientific study on this. So you will find across many journal articles which are published on this particular topic, which is urban heat island effect. The steps involved in performing this study is very clear from the literature. You can easily perform. Even it's not that only MTech people are eligible to write or convey scientific papers, even BTech people can do it. So that's what we strongly emphasize and we believe. So we at CivilTech, we always encourage BTech students and MTech students to publish the scientific works, because if MTech people are applying for PhD, then you'll get an admission in a good university abroad, and similarly if BTech people are applying for MS, and if you have a scientific communication from you, definitely you'll be preferred over the other, and you'll get even stipend as well, which is quite difficult these days. So that's why whenever you try to look at a particular problem, you need to look at scientifically and then draw meaningful conclusions rather than doing the work just like that, right? So this is the first example with which it is very clear that if I use GIS, it is very easy for me to obtain the data and to find out whether the city is experiencing urban heat island effect or not. Now let us move on to the another example. So this is just to emphasize. So this is a snapshot of various studies that were conducted over the globe, and you can look at that they have estimated the land surface temperature, of course, which is required to know whether the city is experiencing a higher temperature related to the surrounding areas. So if you look at the type of data what they have used, majority of these studies used satellite images, right? And moreover, satellite images will not be like the photographs what we take with our camera. So if we take something with our camera, we can easily identify what is there or what we have captured. But if you download the satellite images, so understanding it requires some preliminary knowledge, so which will be very clear if you know the basics of GIS and remote sensing. So you need to play with this data. You just have to blend it and then create a composite image with which you can actually analyze and then draw some meaningful conclusions, right? So the main intent of presenting this particular data sets or this particular information is you need to know the importance of the satellite images and the importance of how we use GIS or how we use this GIS. GIS means it's not a subject, it's a system, right? The softwares, whatever are there. So the way how we are treating the images and then getting the desired output, right? So you need to make a note of, so you need to have a GIS system to analyze the data, and data, obviously, if you get it remotely, which is called as remote sensing, without touching the object, I get the data, right? That's what remote sensing is all about. So the satellites, without even touching the ground, it is capturing what is there on the ground, right? Even your camera, you are doing a remote sensing. You are not touching the person in front of your camera, but you are getting how he look like, everything, all the details, right? So the major things what you need to understand here is you need to have a strong software package that helps you to analyze the data set, and the data should also be available for you. All right. So now let us move on to the next example, which is in the field of transportation engineering. Now let us consider one small example. So this is, let us say this is your home and there is a hotel which is close to your home. So this is one of the famous term, spatial accessibility, which plays a vital role in creating a smart city, right? So now if I ask you a question, how easily can you reach this hotel? That depends on multiple parameters. So one, the condition of the road network which you are using should be very good, and there should be availability of transportation services. Let us say there should be an auto rickshaw service, or there should be a public transport, or if you have your own vehicle, that is absolutely fine. And if you just closely look at distance, is also one of the criteria that decides whether you want to go to the hotel or not. Now let us consider on a Sunday, no one are there at your home and you want to eat somewhere in the hotel, and if the hotel is, let us say, 100 kilometers away from your home, then definitely you don't want to go there. Probably you may prepare something in your home. That means your decision in reaching the hotel depends upon the distance as well, and service of the hotel. So if they don't serve a good food, then definitely you'll not prefer it even it is very close to your home. And if they serve very good and if the distance is moderately okay, then of course you'll again prefer it. So these are some different parameters which decides your choice to go to this particular hotel, right? So when you want to measure this spatial accessibility, you need to know what is the distance from origin to the destination. If there are multiple hotels, then of course, so let us say there are two hotels, then you need to know the distance between the two hotels and all. So for defining the spatial accessibility, you cannot go on the streets, take a tape or a total station and then find out the distance between an origin and destination. It's an old fashioned. Nowadays the Google Maps what you're using, it's also a product of GIS, right? So when you want to find out the distances, then definitely you need to use the maps to find out the distance between origin and destination. You'll come across this in various research works that are being published widely. So since it is only 2 points in the previous slide, it was very easy for you. But if you work at the city level, if you just look at the point data set in this particular figure, there are multiple points in order of, let us say, 500, 600. So then if I just ask you to find out the distance between each and every point, then of course it will be very difficult for you. But if I use GIS remote sensing techniques, in seconds I can find out the distance between each and every point, right? So this is also one of the famous research works which are being carried widely. So you can find out the spatial accessibility, and finding it is very easy, but presenting it to someone to understand it very easily is also a prerequisite. But with the use of GIS, you can prepare maps of your desired interest and then you can present it to the end user, right? So this is another application in the field of transportation engineering. Now let us move on to the next example, which is coastal flood risk analysis. So you're all aware that recently even in Hyderabad, so there were floods. So no one actually expected that floods will come in Hyderabad, but it has come. So the main reason, Niti Aayog by central government, so they have published one recent report that encroachment of lakes is the main reason for the floods in Hyderabad. Why? Because they have occupied few of the lakes which are relatively at a lower elevation compared to the surroundings, and they have constructed all the buildings over there. So then you want to analyze how the land use pattern or how the city has grown over the years. That will actually help you to identify which particular locality is at a higher elevation or which particular locality is at a lower elevation. So that will actually help you to find out where or which region is prone to floods, right? It's very easy for you to do it. But if I ask you to do the same exercise using the typical surveying techniques, so let us say I've given you a total station or a dumpy level and ask you to prepare a contour map for a particular city which is occupying an area of let us say 100 square kilometer. So then definitely it is not that easy as you have done in the surveying lab. In surveying lab, what do? We just divide everything into grids, and we were not even ready to divide a 20 meter by 30 meter at 1 meter interval. So we take 3-4 meters interval to reduce the number of points, right? So time is a constraint over there. But if you know how to download the satellite imagery, how to process it and how to analyze it, just in fraction of seconds you can find out or you can develop a three-dimensional model using the concepts of GIS and using, of course, using a software, right? So just to demonstrate this, I'm going to show you one example. So this is how typically a satellite image will look like. So since probably few of you might have already seen these kind of images, but for bachelor levels probably lab will not be there in many of the colleges. So this is how a typically a satellite image will look like. But if I can use the tool, I can develop a three-dimensional model of a study area just in seconds. So then I can create my own layers and then find out which is at a lower elevation very easily, right? So this is the major advantage of using GIS in the field of civil engineering. Now let us move on to another example and see how interestingly we can expand the applications of GIS. Now let us say there is a big river, and if I ask you to find out the water quality at multiple points, right? So even if, for example, a river, a stretch of 100 kilometers is there. So in these cases, if I ask you to collect water samples and then find out, it will be very difficult for you, right? You need to collect a sample, you need to paste a sticker on it so that the location is known to you once you go back to the lab. And then finally you try to either use a turbidity meter or some other device and then finally find out what is the water quality. But without even going to the field, it is quite possible to evaluate the water quality just by establishing a correlation. Many studies were done. So even during the COVID time, pre-COVID and after COVID and during COVID, what is the water quality? So you all would have known that the water quality of Ganga River and Yamuna River has rejuvenated. So this, it's not by simple analysis. We can use this satellite images to just find out how the water quality has drastically changed over the years. You just have to know which satellite image, which tool, what algorithm has to be used, and how do we finally draw the output. So just key things are required in order to find out this, or in order to carry out this kind of study. Now it has even the applications of GIS and remote sensing has even penetrated into the structural engineering sector these days. You would have seen drones, everyone are using it, right? So this is called structural health monitoring. So technically we call it as structural health monitoring. So what in that particularly what they do is they take a drone, they fly it around the object, they capture images at multiple angles, and then they develop a three-dimensional model, and they do a similar exercise at finer time intervals, so that if I take it today and then tomorrow, I can compare the tomorrow's image with today, right? And then I can find out if there is any crack or something like that. So these particular type of exercises are being done in many areas. It is not just the bridges. In the power sector also they use this kind of skills, and very few people are trained to do these kind of surveys. So if you are experienced enough to process the imagery, then definitely there are many career objectives for you, right? So what you need to do, you need to just process the images. You need to learn certain coding skills as well in order to perform these kind of studies. So this is another application where the use of GIS and remote sensing has been extensively used. Now let us look at one more example, so which is air pollution mapping. So air pollution mapping is a major concern. So I can't install a sensor over each and every point within a particular city, right? So there is a central pollution control board which has already installed sensors in major metropolitan cities, but you need to make a note of that these sensors are confined to particular localities. But let us say if I want to find out air pollution over here where there is no sensor installed, then how do we do that? So then we use spatial interpolation techniques in order to map how the air pollution is varying over the entire interpolation techniques, right? So if you just know how to use the tool, that alone will not serve the purpose. You need to justify whether the obtained results are good or bad, right? So you need to know whether, you need to judge whether the output whatever you got is a credible assessment or not. For that you need to know certain math, how these tools work, which probably many people may not emphasize on, but you need to know how these tools will also work. That will actually help you to find out, and with confidence you can say that this is the correct result, right? So let us take a small example and just try to understand the math behind how these tools work. Let us consider a small area, and then I have installed multiple sensors over here. So this is sensor 1 and this is sensor 2 and so on. So these are my sensors, and then I want to know what is the air pollution at this particular point. Then how do I do it? So when I say interpolation, we try to predict what is the value in between. That's what interpolation we are aware of. We are aware of linear interpolation, right? So I've mentioned the same in the next slide as well. So how do I measure the air pollution at an unknown point? So obviously I'll consider what is the value here, 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 and then here, and then here. So if I define, I need to consider this as well. So depending upon my search radius, and then depending upon the type of algorithm we follow, we come to a conclusion that the air pollution at this particular point is, let us say, 29. If I know the values, just an example, just a random example. So let us consider one small numerical and then try to understand how the air pollution is going to evaluate it by using this particular software, right? So let us say these are my few points. So there are three different methods. One is nearest neighbor interpolation, local average interpolation. So in the nearest neighbor interpolation, the math is very simple. So this is my point where I need to find out the value. So whichever is closest, whether E6 is close, E10, E9, E8 or E5. So let us say E9 is very closer. So what is the value of E9? Let us say 29. So I'll just take the value of the unknown point as 29 straight away. There is no brilliant math involved in the nearest neighbor, right? So it is just whichever is closer, I just take that value. In the local averaging interpolation, we enhanced the algorithm wherein we specify certain distance. Consider all the points within the search radius of 35 meters. So let us say that is the constraint what I have given to my algorithm. So this is the point I need to forecast. Then I will consider majority of the points, of course all the points within the search radius. I'll take the mean value and then try to demonstrate that the air pollution at this unknown point is the average of all these. And there are two more spatial interpolation techniques which are widely used in various research works. One is inverse distance weighted interpolation and kriging interpolation. Even in kriging you'll have multiple, but due to time constraint we have just demonstrated with a small numerical and then demonstrated this inverse distance weighted interpolation technique. So let us consider 3 points over here. So this is my unknown point, right? So I know the value here is 52 and I know the value here is 50 and I know the value here is 30. And I know the distances between these points as well. So distance between this point to this is 10 meters, 9 meters and 20 meters. So just inverse distance, right? So this is how I apply the math and then compute what is the air pollution at this particular locality. So this is how we compute. This is how the algorithm computes. You just click run in the software. That's it. Everything will be done by the software. But you need to know how this algorithm will work. Then only we can actually get to know whether the results what we obtain is good enough or not. Now let us move on. So this is a same example with some more explanation. So we can, instead of following here, so I can even use square, right? I can even use cube. So everything can be used. We can have a higher number of n, but typically n value will be always considered as 1, because if I keep on increasing the power, of course this is inverse, right? This value will keep decreasing and the effect will reduce. So that's why the software will prompt you to define the value of n. If you don't determine any value, by default it will take 1 as a default value and then give you the end result, right? So this is how we determine the quality of air pollution, or it could be any meteorological parameter, or I can say any geostatistical parameter. It can be variation of pH, variation of turbidity, or any water quality parameter within the aquifer, right? So if you know, if you have a case study and if you have multiple points where the fluoride concentration is there, you can find out the fluoride concentration at an ungauged point. So this is how, and this is where we use the concepts of GIS in order to find out, right? So this is one of the small example just to demonstrate how we are going to interpolate the values. So very easily we can find out the variation of the chosen parameter over the entire area, pixel by pixel, without even doing any field survey. So that's the beauty of GIS, right? So let us look at the available tools in order to perform these experiments what we have seen. So there are multiple research topics what we have seen on which you can definitely work on, but you need to know the basics of the software. So there are two softwares which are being widely used, which is ArcGIS and QGIS. So this is a commercial software, so you need to buy it, right? So you need to pay nearly 4-5 lakhs to get the license, and this is an open source, so you can just download it and start using. But trust me, the functionalities are more or less similar, so you can do each of the examples what we have discussed so far using QGIS very easily. But you need to spend little time to understand how the software works. You need to know where you get the data from. You need to know how to process it. There are several sequential steps you need to understand, right? So because not every data is readily available, you need to prepare the data, you need to polish the data what you get it from online. You need to know several techniques in order to do that. So just looking at these, looking at both the perspectives, both at the academic perspective and the research perspective. Academic, wherein BTech projects, people are struggling these days. We are getting multiple requests to create a short courses. So we even taught few of the faculty members in the last month. So we created a separate course which has more research flavor, which has more experiential learning. So the basic overview of this course is, it will be of 9 hours, 9 days. So it will be flexible for everybody. So depending upon the request what we get, we fix the timings, but typically it will be in the evenings so that everyone are free from the academic or any job works. So we provide a basic understanding of GIS and remote sensing in the very first lectures so that everyone will brush up their concepts. And then, so since it is an open source, you can install it in your own laptops. So we will show you a step-by-step procedure how to install QGIS, and then different exercises are designed for the beginners. It is assumed that you don't know anything, and then the exercises are designed so that everybody who has registered will get benefited of these sessions. And 45 different exercises were designed. So GIS just gives us the output, but you need to do some analysis later also, for which the techniques in Microsoft Excel is required. So these 45 exercises are differentiated into two things. One is QGIS exercises, and we even train you on Microsoft Excel in the last lecture. And at the last we teach you few of the multi-criteria techniques, which is especially for the MTech people, so that you can publish the scientific studies. So we teach you analytical hierarchy process and the Topsys technique. So details will be shared with you later, and we assure you that each and every student in the cohort, whoever has registered, whoever has come on board, will be at the end of this particular course. So he'll be proficient to use QGIS, and he'll be able to create maps, create information in terms of maps, download information, everything, and especially he'll be able to carry a scientific research and get a good outcome out of it. Or he will be able to definitely do BTech project with ease. If you know all these basics and all, we even support in the evenings, one-on-one sessions will be there. So just to conduct everything smoothly, so we have conducted these are the different experiments what we have designed. So 44 plus 1, that's based on Excel. So 2 more exercises will be there, and this is planned to be done in 8 hours. So 1 hour each day in the evenings, and so to just run it smoothly and for the logistics purpose. So this is the price what we quote. So if one person registers, so it will be 1,999, and if a team of 3 approaches, so it will be 1,699 per student, and if it is a team of 5, so we quote it as 1,499. So trust me, this is merely very less, and this is just for logistics purpose, right? So we need to have our own server, and also of course we need to manage those expenses. And if you wish to get the same course, definitely it will be in the order of 12,000 or 5,000, depending upon the institution to institution, varies between 5,000 to 12,000. In the Bangalore region it will be around 12,000, but in Andhra, Tamil Nadu, Karnataka, not in Bangalore especially, in few states of few parts of Karnataka, you'll get it for 5-6,000, right? So have a look at it. If you feel that you can, or if you want to do a good project, or if you want to contribute some research articles scientifically, definitely we are there to help you up. So this course is well designed, and so details will be shared with you all later. Interested participants can join the course, and we welcome you on board, and definitely we ensure you that each and every of the participant will gain the knowledge right from scratch to be a proficient level. Thank you all for attending this session. Right. Thank you. See you. Bye.